Dear learners, welcome back to NPTEL online certification course on novel drug delivery systems. I am Dr. Satish Devanapelli, Assistant Professor at Department of Pharmaceutical Science and Technology, Institute of Chemical Technology, Mumbai. In our novel drug delivery systems, we are learning on protein, peptide and nucleic acid delivery systems. In that, so far we completed 3 lectures on introduction to protein peptide delivery, and then we have seen key considerations for protein peptide delivery, and then we completed in our recent lectures the barriers for the protein peptide delivery systems, and then today we are going to see on some of the new topics on the protein peptide delivery. So, in that we are going to discuss today on protein peptide delivery strategies. So, before going that, we will focus on some time on the routes of delivery. So, here of course, when it comes to the routes of delivery, we have various types of routes of delivery. Now, here it is classified based on the invasiveness. So, the first one is the invasive, nothing but parenteral route, and the another one is non-invasive routes of delivery. And again, in the parenteral, or you can say the invasive approach, that is intravenous, subcutaneous, intramuscular and also intracerebral type of formulation. Not only limited to this, we have the IVT, intravitreal therapy or intravitreal injections. There we use for the delivery of the drug into the eye. There are other types of routes are there, but we have focused here. We are going to see on the very few type of invasive approach which are known, and non-invasive we are going to discuss on the oral delivery and the pulmonary, the nasal and the transdermal approaches. So, parenterals, in that we know that there are the few essential requirements for any type of parenteral formulations, right. It can be abbreviated in this way: S, I, P and P. Nothing but any type of parenteral, if you are claiming your product should be sterile, that means free from all type of living microorganism. Second is your product need to be isotonic, that means the solute concentration of your formulation should be equal to the blood solute concentration, that means equal osmotic pressure with the blood, that is called as isotonicity. There are the two conditions, hypertonic and hypotonic. Such cases, hypertonic cell may undergo shrinkage. In the hypotonic, cell may undergo swelling and leads to the burst that further causes the hemolysis, right. So, now third P is nothing but pyrogens, that means free from pyrogens, okay. And the fourth one is free from particulate matter. So, this is very, very important. SIPP. The product should be sterile, isotonic, free from pyrogen, free from particulate matter. Then your product is called as sterile formulation, or you can say the parenteral formulation. Otherwise, you cannot use it. These are the minimum essential requirement for any type of parenteral formulation. Either it may be pharmaceutical drugs, biological, proteins and peptides, any formulation, even it may be biosimilars. then it can be eligible for any type of routes. Now, here you can see the different products, and these are the different therapeutic molecules, and these are the different routes which are already in the market. Now, you can see all type of their products in the picture. These are the various indications we will use it for the treatment. Now, you can see here vasopressin injection, Indian pharmacopoeia, 20 units per ml. It can be given intramuscular, intravenous and subcutaneous. And here also octreotide acetate formulation. So, again this is comes in the injection format, 100 microgram per ml, and here also you can see oxytocin that will use for the labor induction, right. It can be given in the IV, right. Also this can even give in the infusions. And similarly, we have salmon calcitonin that we use for the hypercalcemia. It comes in the 400 IU, and again that can be given in the intravenous and subcutaneous route, which from the Mylan, and this also from the Mylan and the Novartis, and this one is from SG Pharma company. So, yes, you can give whenever your molecule is very high, large molecule, and if it is not compatible with the oral or any other type of non-invasive route, you can prefer either intramuscular, intravenous and subcutaneous, and the dose and the routes of administration will be different. Now, coming to the second routes, that is the oral delivery. Here, yes, we have various routes, right, various types of formulation, I mean to say dosage forms. You can use liquids, whereas in the parenteral you can use some cases suspensions, you can use the emulsions, we can use clear liquid solutions. There are the depot formulations also can be used. When here it comes to the oral, yes, we can also use solutions, we can also use in the tablet formats, capsules, and not only that, we can use granules and various types of formats which you can use it. Even in the tablets we have various types. These all can be used, and not only that, we have different target system, like in the mouth we can come up with the sublingual tablets, we can use buccal formulations, either it may be patches or buccal tablets, right. Even mucoadhesive films, that is also possible, oral disintegrating films, oral disintegrating tablets, right. Even nowadays we have interesting formulation which comes in the oral sprays, right. So, these are all which are in the upper region of the mouth, right. So, if you go further, we can target to the small intestine and the large intestine, right. You can go even with the enteric coated formulation with the different formulations, right. So far we discussed on the different dosage forms of the oral route. Now, here is the some of the approaches whenever you want to go for the oral delivery. So, these are will be the outcome for your protein peptides. Yes, as we had discussed, I am not going to discuss again detail in this, because we already discussed on the amino acid modifications, even the hydrophobization, right, which will improve the stability as well as the penetration, right. And the second one is enzyme inhibitors, which will inhibit the degradation by the enzymes. So, we discussed already about the what type of enzyme inhibitors, how it will work, and we will focus on the absorption enhancers and how that will improve the permeability. Then we will focus on the formulation vehicles, that is emulsion, microspheres, nanoparticle liposomes. This already we discussed in our week 2 and 3 on the various types of nano carriers, okay. And then mucoadhesive systems. So, here you can see the chemical modification. We can use polymers, which will also control the deamidation during the formulation as well as storage, which can survive the all type of degradation process which may happen into the blood as well as by the oral route, also in the stomach and the intestine. So, this is one example Nobex oral insulin. By using of this we can modify and you can use it for the oral delivery. And hydrophobization, nothing but adding of palmitoyl groups into the insulin, that will increase the hydrophobicity, it will help for the permeability. Now, enzyme inhibitors, now you can see the picture representation. Yes, insulin can degrade it by using of digestive enzymes like pepsins, and enzyme inhibitor which will protect and improve the absorption when you are taking oral route. Now, you can see here is the biomolecules when you give, which will alone which will not enter into the biological membrane because of that enzyme undergo degradation, and you will see the very less amount of the uptake of the biological molecules. When you are doing some interaction, intermolecular reactions, or when you are conjugating or making a biomolecules with the enzyme inhibitors, that enzyme inhibitors will cleave into the oral site, into the mucous layer, and that will inhibit all type of enzymes first, then your molecule will come and release in through intestinal membrane, and further it will reach to the blood. Okay. So, with this we can use various types of enzyme inhibitors. Now, you can see insulin can be break down into the various amino acids, and you can use serine protease, thiol metalloproteinase. So, that will leads to the degradation. These are the inhibitors you can use for the trypsin and chymotrypsin and insulin degrading enzymes. Okay. So, these we can use it for the as an inhibitor, we can mix with your formulation as well as you can also conjugate with this type of inhibitors. Even the sodium cholate, it works as an enhancer, it also works as a protease inhibitor that will improve the 10% of the insulin in the rats. So, here also you can see one more strategy directly by modifying the pH, that will definitely stop the functions of the enzymes. So, lowering of intestinal pH to 4.5, that will inactivate the enzyme. So, best example is trypsin, chymotrypsin and elastase, which can inactivate by decreasing the pH into below 4.5. So, this is one more strategy, this can be done by adding of the pH modifying agents to the formulations. The third one is absorption enhancers. As we see, the large molecules cannot cross the blood brain barrier. By using of absorption enhancer, which will help, which will change the cellular structures in the membranes. So, they may temporarily loosen or disturb the barrier like a cell membranes or tight junctions in the intestine. This we have already discussed in, if you remember, in the ethosomes we have proposed various mechanisms how ethanol will loosen the skin membranes. So, similarly, here also these are the absorption enhancers. So, that will disturb. Now, you can see here these are the tight junction which are in the intestinal epithelium, but when you use such type of the absorption enhancers, you can see there is a disturbance which is happening in the cellular level. Okay. So, that will disturb the tight junctions and the cell membranes. So, that leads to the entry of the molecules by using of the absorption enhancers. Now, here you can see these are the classifications. We can use surfactant as an example of absorption enhancers, chelating agents, fatty acid derivatives and the polymers, sodium dodecyl sulfate, which will disturb the cell membrane, it will allow the drug entry, but yes, which can cause the cell damage because of the surfactant very dangerous to the cells. And EDTA, yes, we have to use in the limited concentration, right. So, based on that we can use it. Again EDTA, it undergo the chelation, that will also help in the changing the function of the tight junctions. And fatty acid derivatives, sodium caprate, long chain acyl carnitines. So, that will also improve the absorption. So, they are safe and well tolerated. Polymers, as we know that chitosan derivatives can also reduce the electrical resistance across the intestinal cells, which will improve the absorption. You will do not see any type of damage of the cell because of the chitosan itself is a biodegradable as well as biocompatible, and which is also proven as non-immunogenic. So, we can use such type of the polymers for the delivery. Now, here we have the formulation approaches. As we discussed in our previous lectures like lecture week 2 and week 3, we have discussed detailed on the various types of nanocarriers like liposomes. We can use solid lipid nanoparticle, polymeric nanoparticles, also inorganic micelles and the microspheres and microcapsules. Yes, with that what we will understand. So, we will get the protection from the all type of enzymes and harsh conditions at acidic pH, and not only that, you will get a targeting also by using of nanocarriers, and also you will see the controlled release. So, these are the major 3 advantages when you are converting into the nano formulations. Now, here you can see the emulsions. Of course, we need to understand what are the components involved in the emulsions, and definitely which are comes into the biphasic liquid dosage forms. The emulsions are biphasic liquid dosage forms. We have a 2 phases, one is oil phase and another one is liquid phase. Here the major component comes is emulsifying agent. Okay. Yes, here also we have different sources, that is the stabilizers, natural as well as semi-synthetic and synthetic, based on the requirement and the purity we can select. And also we need to understand the role of emulsifier on the activity and stability of your formulation. And emulsifier also can be classified into cationic, anionic and non-ionic, and again the charge also very important based on your molecule. So, based on that, so if you want to improve the solubility as well as permeability and you want to stabilize, you can go any type of emulsion. So, preferably micro emulsion, nano emulsion. Nowadays the interesting field is self micro emulsifying drug delivery systems. So, these systems will help in the improving of solubility as well as this will improve the permeability of the formulations. So, yes, both are different formulation, one is thermodynamically stable, another one is kinetically stable, right, and the nano size which may come below 100 nanometers and it may come 100 to 200 nanometer, their energy is required, and here we use oils, surfactant and co-surfactant, and this is very clear and transparent emulsion, and here you will see some hazy and white type of emulsions. Yes, so with this we can improve the stability as well as solubility and permeation of the molecules. Now, the another formulation approach is by using of microspheres. So, the best example is pH sensitive polymers. If you want to protect for oral delivery, you can use entry coated polymers or the polymers which will respond, like in a udrogid also we get various types of the pH sensitive polymers which we can use it, and we can load your molecule which will not release in the acidic condition, and not only that, in the basic condition or you can say intestinal pH, the drug will release slowly, that will help us for the controlled release. So, this will swell and release the drug and also protect from all type of physiological as well as the environmental conditions. So, target release possible, high absorption. Now, you can see the coating with the polymers, and at that particular pH your molecule will release. Okay. So, here we can prepare micro capsules as well as micro spheres, and the size will go more than 100 nanometers, or you can get it will be more than 1000 nanometers. The size may go from 1 micrometer to the 100 micrometer based on the your application. This can further utilize in the even in the capsules format, also you can use it in the as in a pellets, or you can use it in the tablet formats also. Yes, this we already discussed the nanoparticle, the size which comes from the 100 to 1000 nanometer, but in practical we use in a 100 nanometers when you want to go for injection, even 500 ml, 500 nanometer also preferable when you are going for the oral application. So, yes, this will happen with the PS patch, and yes, you can also protect it from the degradation of the all type of enzymes, because simple PLG and chitosan that you can use it and you can convert into the nanoparticles, and their release and the therapeutic efficacy will be very high. So, less than 5% nanoparticle can reach to the bloodstream. So, that is one of the limitation with some of the particles, but by understanding the nature of your molecule and the nature of the polymer, you can achieve the maximum loading as well as you will see the improved therapeutic efficacy of the carriers. Yes, particle size, surface charge and surface coating will affect the bioavailability as well as therapeutic efficacy of the formulation. Liposomes, here we use bilayer vesicles, and this helpful for the improvement of the solubility as well as permeability, and you can avoid the degradation from acid, bile and enzymes. Yes, surface coating with PEG like pegylated liposome can be possible, that will improve the stability as well as decrease the release and control the release and improve the prolonged blood sugar level if you want to go with the like insulin, and you can also coat with the PEG, that will help for the prolonging the half life of the formulation. The another one is mucoadhesive polymer systems. Yes, this already we discussed in a mucosal drug delivery. We use various polymers. So, based on the different nature, also from the source of synthesis, also with the charge, right. We have different mechanisms also for the mucoadhesive. Okay. So, yes, mucoadhesive is one of the approach which that we can improve the retention time, and also we can stop the degradation, and by using a mucoadhesive polymer, it works as a mucoadhesive as well as a controlase polymer, which will help for the site specific delivery as well as we can improve the bioavailability. Yes, polymers stick to the mucin, that is the main component of mucus, which will protect from the degradation from the mucin layer, right, and the drug more time to absorb, and that will release absorption enhancers. So, this ultimately will help for the improving the release steady as well as therapeutic efficacy. Now, we can see these are already we discussed synthetic and semi natural and natural products, and also we can classify into 3 categories: anionic, cationic and the thiomer. Even non-ionic also can be possible, like using of hydrogen bonding and the electrostatic interaction and the covalent bonding with the mucin, that will improve the, you can refer my previous lectures. So, pulmonary delivery also possible by converting of this into the pulmonary systems. So, because the large surface area is one of the attracting option for the pulmonary delivery, and they have rich blood supply, we already discussed in the nasopulmonary delivery systems. You can refer that introduction chapter, so which you will understand the importance of pulmonary delivery compared with the other routes of delivery systems, and main thing that we can avoid the all type of degradation which are going to happen in the intestinal route, or you can say the oral route. Okay. So, again it is a great thing, it is one of the best option for as a non-invasive when you want to avoid the oral as well as parenteral. The pulmonary is one of the beautiful delivery system, with that you can improve the safety and efficacy of the patient. So, yes, such large molecules can be converted into the pulmonary formulations. Here we can add these surfactant, fatty acids, sugars and chelating agent and enzyme inhibitors will also help as in a pulmonary delivery systems. Now, we can see we can use large particles that will trapped in the upper airways and the reach small particle will reach into deeper lungs, and here we need to use some of the device like ultrasonic nebulizers, meter dose inhaler, dry powder inhalers, so such carriers can be translated and delivered into the pulmonary route. So, preferably 5 micrometer is preferable for the to show the high efficacy. So, by intranasal, yes, if you want to, whenever you want to deliver other than the parenteral, and this is also one of the non-invasive approach, which this we can deliver the products. So, that is non-invasive, easy to use and preferred by patients, and intranasal delivery is an alternative route for the all type of peptide formulations, and even if you can also target for the brain also. Smaller peptides, better absorption, peptides greater than 14 amino acid, very low absorption, that is less than 5%. So, we need to understand the properties of the proteins and peptides. We can convert into different formulations, microemulsions, spray dried powders. We can give into nasopulmonary route, and in case of nasal, we can give with the sprays and even in situ gels, so that that will easily bound to the nasal cells, and you can see avoid all type of, in case of even brain delivery, we can use the intranasal delivery, which will bypass all type of barriers in the brain delivery. So, we can use the chitosan derivatives, cell penetrating peptides, cyclodextrin, gelatin, nanoparticles, hydrogels, microspheres and liposomes. So, these are some of molecules we can use it by using of intranasal delivery. And the last approach, that is the transdermal delivery, we know we have discussed on the microarrays. So, with that also these are the tiny patches with that we can deliver the molecule into the skin. So, transdermal is one of the approach, but the major drawback is the permeability through skin is very critical, and also these have large molecule. Permeation is one of the major problem. You cannot use simple transdermal, you have to use microfluxes. So, with that only you can deliver the systems. So, it is nothing but transdermal patch designed to deliver the biopharmaceutical drugs like peptides and proteins through the skin, which will deliver the drugs through control and consistent effectively and minimize the discomfort. You don't need to use any needles, user friendly, and provides reliable dosing and better drug absorption. Whenever you want to give any enzymes, vaccines and protein peptides, microflux is one of the good advantage. Now, you can see in the picture representation, the drug coated microflux will be like this. We have to place in this ring, and then we have to put the patch applicator, and then we have to apply on the patient. After that, you will see the after administration it will be like this. So, it contains titanium micro projection arrays, that is tiny needles, nothing but micro needles which contains polymers, and yes, we can avoid all type of problems. We can also coat with the drug on the tips and it absorbs into the micro capillaries. We can avoid stratum corneum barrier in the transdermal delivery systems. So, with this we are going to stop here. So far we discussed on the protein peptide delivery systems. In our upcoming class, we will discuss on nucleic acid delivery. Thank you so much. See you soon.